Buddy, and today we are going to discuss matrix multiplication program. So, as we discussed yesterday, we did start off with this program, but we could not complete it. So, let me just again restart the same slide once again. So, in this program, we are going to multiply two matrices. Now, when I say two matrices, I'm going to consider the first matrix as A, the second matrix as B, and then to obtain the first value of the product matrix, I need to multiply the elements of the first row of the first matrix with the first column of the second matrix. So that is what I have shown here. So 1 into 5 plus 2 into 0. That would be my first element in the product matrix. So 1 into 5 plus 2 into 0 would give me 5. So I'm writing it down here. Now the second element here is the summation of products of the first row and the second column. First row and the second column. So 1 into 6 plus 2 into 7. So I get 20. Now this is a common procedure that we have been following. I think you would have studied these in your school days and you could still remember it. But what is interesting here is we need to identify which row and column values are supposed to be multiplied and then added. Now, if you observe this representation here, I have matrix A and matrix B here. Matrix A has 3 rows and 2 columns, whereas matrix B contains 2 rows and 3 columns. So we know that if the column of the first row is equal to the row of the second matrix, column of the first matrix is equal to the row of the second matrix, then we can proceed from finding the product of both the matrices. Now this is how it is given. So if I want to calculate A of A into B, then I'll multiply the uh, element, the first row elements to the first column elements, and then find the summation of it. I want you to observe the index values of these elements here. Now, in fact, in my program, or rather in C program, the index will obviously starts from 0. Now, this is just for explanation's sake. I've taken it as um, 1 1 and 1 2, or else in my C program it is going to be represented as 0 1 0 0 0 1. Then this is the second row, right? So 1 0 1 1 2 0 2 1. That is how it is represented. Let's understand how it is, how these values are accessed, and at the same time see the variation in the index values. Now if I see here, this first element is multiplied with the first element of the second matrix. So E of 1 1, B of 1 1, and then it is E of 1 2 into B of 2 1 into B of 2 1. See the indexed values here. So here it is 1 1 1 1 1 2 2 1. If you see the pattern here, if I consider this as the first iteration, see the value of the first index here. It is 1 throughout. In the second row, you will see that it is 2 throughout. In the third row, it is 3 throughout the entire row. Okay. If you see the second index of A and the first index of B, it is same throughout. See the first row, you have 1 1, then 2 2, then 2 2, then 1 sorry 1 1, then here 1 1 1 1. But in the second row also you will see 1 1 2 2 2 2 1 1 2 2. Third row it is 1 1 2 2 1 1 2 2. But observe the last index here, the fourth one. If I consider A and B here, the fourth one, it is 1 1 2 2 3 3 1 1 2 2 3 3. So there is a common pattern that we need to follow. Now, what is that pattern? Let me represent this A B as uppercase A and B here, and the index values here in the form of A, I, K, and J. Now, the second and the third indexes are same everywhere. See, if I have 1 here, the third index will also be 1. If I have 2 in the second index, the third one will also be same. So what I am trying to do here, I am going to represent these index values in the form of subscripts here. So IK, KJ. So K is common in both the elements here. I and J varies. Okay, now let me show you how to write the program and how to execute the program. So having understood this, we will see the program implementation. I Are you able to see the online editor now? Guys, are you able to see the online
Yes, sir.
editor? Okay, fine. So let me just type the matrix multiplication program. Okay, so I have hello world here. Let me remove it. Integer. So to multiply two matrices, then I need three two-dimensional arrays. Let me represent it as A first, uh, matrix as A, and I'll just have the size as 5, then again 5. I'm not going to go beyond 5 cross 5, so I will just do that. Okay, so this also let it be 5, B also let it be 5, then I will go with C. Just because there is no par, so let me yeah. So yeah, next C also I will uh, have it as 5. So I may require few other variables for the loops. So I j k will be using, and most importantly require variables to store my rows and columns of the uh, first and second matrix. So I am going to declare four variables: m, n, rows and columns of the first matrix, then p, then q, the rows and column matrix of the second matrix. Okay, so what I will do here is I'll just say printf. Let me first accept the values. Printf, I'll say enter the uh, rows and column of the first matrix, or I can also say matrix A. Okay, let me put a slash n here. So let me accept it. Scanf. I'll say I missed out this one. Percentage uh, percentage d. Then I'll give another percentage d for the second for the column. So let me accept the first row. First row here I will represent it as m, and then column would be n. Column would be n. Okay. So I will accept this. Now, after accepting it, accepting the rows and columns of the first matrix, I will now accept the rows and columns of the second matrix, right? So I need not type this again. I will just cut, copy, paste. So instead of first matrix, I'll change this to um, second matrix. But here instead of M and N, I'm going to give it as P and okay, P and Q. So after accepting it, I cannot directly try to find out the product of both the matrix. I need to check a certain condition. What is the condition that I need to check? What is the condition? Guys, anyone can answer?
Number of
Yes?
number of columns of the first matrix must be equal to the number of rows of the second
Very
matrix.
good. So how do we check that?
If n is equal to p,
Okay. So I will say if n is not, I will slightly change this. Okay. Instead of equal to, I will just say not equal to p. Okay. I'm taking the negation of it. Don't worry. So here I will say printf. Uh, I'll say matrix multiplication. Multiplication is not possible. Not possible. You can give whatever statements you would like to give, and then I will say uh, no, exit is not required here because I'm going to use an else clause here. Else, okay. So I'll just say, uh, in fact, I can also say try again. Try running the program again. The program with new rows and columns. Okay. Uh, don't know why some problem here. So I will just stop. Okay. I think this is sufficient for now. If you want to extend, you can please extend it. Okay. Now, once we know that n is equal to p, then we can start accepting the values and then perform the matrix multiplication. Okay. Um, So what should I do? First, let me accept the elements of the first matrix. So to accept the elements of the first matrix, then I require a printout statement. So I'll say, I'll put another slash n here, enter the elements of the first first matrix, right? I'll just say this, and then how will I accept the elements of the matrix? How many should I have to accept the elements in rows and columns? So how do I go about and accept the values in the matrix? Can I just use a scanf statement like this? Can I say scanf statement? Of, it's a two-dimensional array, right? Guys, are you able to hear me?
yes sir, yes.
Great. So it's a two-dimensional array. So I'll say E of I, E of J. Okay, see the ampersand here, but then I cannot just do this just like that because I need a for loop I equal to 0, I less than m, right? I less than m, then I plus plus. This is the for loop that I require. So m and n is the rows and column representation of my first matrix. So rows first, in here I will have the column is, let me use j starting from 0, j less than n, j plus plus. Okay. And then here I will have the scanf statement. So you can now give the elements for the first array. First array elements are accepted using these statements. Okay, now after accepting the first matrix, then I will accept the elements of the second matrix. So I will just copy it and paste
Excuse
it.
me, sir.
Yes, yes, yes. Yeah, tell me.
So without accepting the values for m and n, how will it verify whether n is not equal to p or
Here we are accepting it, no, scanner. Here, see, that was the first thing
okay.
that we did. We just printed saying that enter the rows and columns of the first matrix. So we have accepted m and n here. Similarly, we accepted the rows and columns of the second matrix here. After accepting it, we are checking whether the column of the first matrix is not equal to the row of the second matrix. If it is true, that is, if it is not equal, then we will say matrix multiplication not possible. If that is not true, which means that both your column of the first matrix is equal to the row of the second matrix, in that case, control goes inside or executes the else clause statement. So else clause statement, now you have accepted the first matrix elements of the first matrix here using these statements, and then using these statements we are going to accept the uh, elements of the second matrix, right? So
Okay, sure.
after accepting it, okay, now we will write the logic for finding out the product of the matrix. How do we find out the product of the matrix? So this is how you need to, guys, you need to type the program with proper indentations. Okay, make sure that you type it with proper indentations. See the spacings that I give. So let this be the logic. Instead of, I don't need printf statement here, so I will just remove it. Ij, again here I don't need a scanf statement, I'll remove it here. But here I need another for loop. But before for loop, I'm going to initialize a C of I. I'll tell you why this is required later. For now, we will just have it like this. And then I will have another for loop. Okay, another for loop. Uh, so let me start with I.
Sir,
Yes. Yeah, yeah. Go ahead.
in the second matrix,
Yeah.
uh, there for
This
should
one.
like
Yeah, yeah.
for
P and
I
Q.
is equal to 0, I less than p.
P and Q. Yeah. Go ahead. Go ahead. What is it? I. Less than P and Q. That is what you said. Okay. Okay. Fine. Um, yes, you are right. So next we are going to
Am-
compute MQ.
So even you need to change the scanner state.
Yeah,
It must be
what
amper
is the
B of
change?
PQ.
What is the change that we need to do?
Amper B of PQ.
No, it is IJ.
Like
See, even here it is IJ. Okay, now I'll come back and explain that. Let me finish this. Let me just finish this typing the logic for multiplying the matrix, and then I'll come back. So this is M. No doubt in that. This should be Q. Um, this should be Q, and finally this should be P. But then I'm going to change the uh, variable in the loop also. This is not J, this should be K. I'll tell you why. K. Okay. um okay, and now guys, now one of you asked me this question. See, if you consider these for loops and scanf statement, this first for loop is to track the rows or to represent the rows. I varies from 0 to m. Now if I is equal to 0, it is representing the first row. Now similarly here it is j 0 to n minus 1. Why n minus 1? because I have the condition j less than n. If it would have been j less than equal to n, then this for loop would have varied from 0 to n. Now it is n minus 1. Similarly here I varies from 0 to n m minus 1, and every time I is going to get incremented by 1, here j is going to get incremented by 1. Now, see the index value that we have given here. It is I and j. Now, what is the value of I first? First time when it enters here, I value will be 0. Okay, I value will be 0. Now, assume that it is 3 cross 3 matrix that we have taken. So, obviously, M would be 3 and N will also be 3. A square matrix basically. Okay. Now, the first for loop will execute. I gets initialized to 0. I is checked with 3 because M value is 3, 0 less than 3. It is true. It is true. So control goes inside your for loop. It will execute this for loop now, inner for loop. It's a nested for loop. Both for loops I have. That is why I call it as nested for loop. If this conditional value is to true, the control goes in. It will start executing this for loop. J is initialized to 0. J is checked with 3 again. That is 0 less than 3. It is true. So control will your compiler will execute this statement. Now when it executes this statement, your I and j value remains 0 0 initially. Okay. Now can anybody tell me the index value of the second element in the matrix? What is the index value of the second element in the first row? Index of the second element in the first row. Is it not 0 1? Yes or no, guys?
Yes, 0, 1.
Yes. So the first element's index is 0 0. The second element index is 0 1. The third element index is 0 2. So what we are trying to do here is we are going to just increment j from 0 to 2. I remains same. So 0 1 0 0 0 1 0 2. And once I increments to 3, this condition will fail. So control goes back and increments I value to 1 now. It will check this condition 1 less than 3. It is true. Again, it comes back to the for innermost for loop, starts j from 0. So the first element in the second row, the index value would be 1 comma 0. Then the second element in the second row would be 1 comma 1. Third element in the second row would be 1 comma 2, and so on. That is how you need two for loops, nested for loops, and the index value is I and j. The same thing is applied for the second matrix also. So that is why I'm copying it and pasting it. The only change that I do here is the rows and columns of the first matrix, which is M and N, rows and columns of the second matrix, which is P and Q, and of course the name that we have given for the first matrix and the second matrix, the two-dimensional array A and B. Only these things are changed. Of course, in the printf statement, it is first and second. Okay, now coming back to the logic here. Now, if you go back to the uh, presentation, the uh, the slide that we saw had the logic behind computing this, um, finding out the product of the matrix. So how do we do that? Okay, Ij is equal to C of Ij plus A of I k into b of k j. This is the one that you need to remember. If you are able to remember this, then your program is done. Okay. Now, how did we get this logic from? Again, let me show you the slide. where we had discussed this. Yeah. So guys, are you able to see the slide now?
Yes, sir.
Yeah. Now just see this formula. I've taken it as Ij, right? A of Ij is equal to the summation of k equal to 1 to m. Now this represents the number of elements. Now if you see this equation, I have here E of Ik, B of Kj, which means that here in the representation of product matrix, when I'm trying to compute it, Ik, Kj are the index values here. Now here we clearly saw that the index of the second element, that is C, is always equal to the index of the second element here. Second element, the column of the first element will always be equal to the row of the second element. 1 1 2 2 2 2 1 1 2 2. So k and k remain same. So you have to have k and k. Ij, I goes on varying. I represents the outermost loop. J represents the second inner loop. K should represent the third inner loop. Okay. And what is this? This is summation, right? So we are adding 1, 2, 3 elements. 3 elements. Now, how do we do this? And we, since we are adding 3 elements, it is a summation of all these three. I mean, here it is only 2 elements. Sorry, it is 2 elements here. 1, 2. Say if you have 3 cross 3, then you should have summed up the 3 elements, 1, 2, and another one. So that is the summation representation here. Okay. Now, how do we do that in our program? Let me show you that. Yeah. So now are you able to see the online editor? Guys, are you able to see the online editor?
No, sir.
Let me share it once again.
Screen is
Now?
Yes.
Yeah, okay. Now how did we do that? So if you observe this A and B, the product that we are calculating here, E of Ik, Kj. So there is no change in this. I'm using the same thing. Now we said summation of this. So we don't just have only 2 elements to multiply. We multiply this and add with the next uh, element, that is the product of 2 other elements. So this goes on, right? So how do we do that? If you see here, we have a for loop where we have k has to execute those many times the time the number of times that we are going to add the elements. Where are we adding it? We are going to add these elements, multiply this and go on adding it into C of Ij. So it is as good as sum equal to sum plus term A into term B. So we go on doing it. So it's a summation of the entire set of elements that we have found out the product. Okay, that is why we have this. Now I could have replaced this statement using sum. I could have said sum equal to sum plus A into B. And here down the line, I could have the next statement, which is not part of this for loop, it should be outside the for loop. I could have just said sum equal to C of Ij. So I'm assigning the value back into the matrix. That is one thing. The other thing is, even before I compute this value, right? Even before this, before I compute this C of Ij, I'm going to initialize it. Initialize C of Ij to 0. And this happens every time the control enters the J loop. Every time. Why? Say I am now finding the product and filling the value of C of 0 0. When I say 0 0, the first element that I generate, I generate it by multiplying several numbers. That is, the I'm going to multiply the elements in the first row with the first column, and I'm going to sum it up. Now, after summing it up, right? After summing it up, C of ij will contain that sum. Okay. Next time when I calculate, automatically after computing the second element will be the summation of the actual second element plus the previous element. I don't want that to happen. Every time I have to compute only the sum of the product of the corresponding row and the column. So every time I need to initialize this C of ij to 0, or else you will not get the right value. Okay, so here I have found out the uh, product of A and B, and the product is now stored in C. Okay, now stored in C. Now what I am supposed to do, I have to print all the three matrices, right? So what I will do, I'll go back, I'll copy A, B, C, I have to print. So I'll go back, I will now try to print the matrix. So I will just make slight modifications to the uh, existing statements, the elements of the matrix, the elements of the first matrix. Instead of scanf, I am going to just make change to this printf, and here instead of ampersand it will be this one. Okay, there is one more change that I need to do. If you remember, this, what should come here? Or else it will not print the elements in the matrix form. So this is what I will be doing. So just copy this, paste this once again. I'll say elements of the second matrix. So this has to change. This will be B. Not only B, this has to be what? PQ. P. This has to be Q. Other things I need not change. Okay. Now I will be printing C. Right? C. So C I am printing. Okay. Okay, guys. So I think with this we will try to run the program. I think we have sufficient. So this is the closing bracket for my else clause. Okay, and this one is for my end of the. Okay, fine. So let me now run the program. Check out whether are there any errors or no. It's going to give us the output, no problem. So 2 again, enter the elements of the first matrix. I will enter the matrix also in the, elements in the form of the matrix only, right? See, it is allowing us 2 1. Oh, we can make certain changes here. Why is it printing like this? It is 2 elements, but then let me just make certain modifications. Let me see even matrix A, enter the matrix of the first element. Okay, now this is one thing that we need to focus on, say the elements of the first matrix. So what we will do is we'll put a /t here. Okay, we'll put a slash t here so that it will give some space between each elements. Okay, between each elements in the array. Okay, this is one thing. So it is working fine. You can manually check. It is 8 5 20 13. It is working fine, but then you have to format it properly, so to make sure that the elements can be clearly distinguished, and you can see the output. Let me once again execute this program. This time I will make slight changes to the inputs. What should be the output of, I mean, will it now accept the values of matrix A and matrix B?
No, sir.
Why? Because the column of the
Because
first
n is
matrix
not
is
equal to
not.
p.
Yes, good. So now certainly it should not accept. So it says print matrix multiplication is not possible, right? So let us execute it once again. Let us execute it once again. So this time I'll give it as 2 cross 2, 2 cross 2. First element elements, second matrix elements. Now see. So you can see here it has displayed the elements of the first matrix. Here it has displayed the elements of the second matrix, and this here it says second matrix, but then you can go and make changes there. You can say product of the matrix. Okay, let me change that. It says the elements, the product, I will say now the product of um, of both the matrix or matrices, you can say uh, R, and then you can just print the product of both the matrix. Okay, guys, if you have any doubts, you can ask me now.